Welcome to the training for Mechanical Science Fundamentals. Print reading. The average time to complete this training is estimated to be 15 minutes. After you have completed this portion of training, you will be directed to the next training lesson in the series for further instructions. Engineering drawings are one of the primary methods of communicating technical information about plant equipment and systems. To read a drawing, it is necessary to understand the standard conventions, rules, and symbols. It is also necessary to understand the information contained in the various non-drawing areas of a print. This chapter addresses the information most commonly seen in the non-drawing areas of a nuclear-grade engineering type drawing. These are the objectives for this course. This module will introduce you to some of the common type of prints used in LWO that you will be using. The prints of interest to operators are those that demonstrate how components, instrumentation, and interrelationships work rather than construction type information. We will look at the following: piping and instrument diagrams, P&IDs, electrical single-line drawings, electrical schematics, logic diagrams. One of the most frequently used drawing types is the piping and instrument diagram, P&ID. These are designed to demonstrate component order in the system. P&IDs illustrate piping, flow paths, major components, and instrumentation. Operators use P&IDs to operate and isolate equipment such as for lockouts, tagouts. P&IDs are not drawn to scale and present only the relationship or sequence between components. Two pieces of equipment may be drawn next to each other on the print, but actually be separated by a large distance. The intent of these drawings is to show how system components interrelate instead of their actual physical size or location. Electrical single-line diagrams serve the same purpose as P&IDs, but for electrical systems. They show power sources, system interconnections, major system components, and electrical loads associated with the system. They are not drawn to scale and do not show physical locations. Power distribution systems and motor control centers, MCCs, are typically represented as single-line drawings. Single-line drawings have a single line that represents all of the individual electrical conductors from one point to another. The drawing does not show system details, but limits itself to major components and their interrelationships. Electrical schematic diagrams provide a more detailed level of information about an electrical system or component than a single-line drawing. Schematic diagrams present information such as relays, relay contacts, fuses, motors, lights, and instrument sensors associated with electrical equipment. Motor or breaker control circuits and valve actuating circuits are typically represented by schematic diagrams. The information contained in each diagram varies with the equipment and the section being shown. Schematic diagrams have a line for each conductor. Logic diagrams provide a simplified representation of control circuits. They don't show components, but instead describe equipment conditions. A logic diagram will represent the required equipment conditions for operation and the equipment's response to various changing conditions. This is accomplished using standard logic symbols rather than a complex electronic component. Logic diagrams provide a quick, easy-to-use reference. However, they cannot replace electrical schematic diagrams because they show no component detail. Logic diagrams will tell you what a control circuit will do, but not how it will do it. There are 5 major areas to a drawing. These include the title block, the grid system, the revision block, notes and legends, and the actual drawing graphic. We will look at the 4 non-drawing portions of a print. They provide important information about the drawing. Failure to understand these areas can result in improper use or misinterpretation of the drawing or using an outdated version of the drawing. The title block, located in the lower right-hand corner of the print, contains information necessary to identify and verify the validity of the print. This block contains the following about the print: drawing title, applicable area or system, drawing number and revision, design review and approval signatures, and reference section. The drawing number is unique to the print and is comprised of a code that identifies the type of print and the affected system. It also contains a sheet number if it is part of a series. Drawings are filed by their drawing number because the title may be common to several prints or series of prints. The revision number is used to verify the validity of a print. The reference section lists other drawings and reference documents that are related to the equipment and other drawings that are cross-referenced on the print. The grid system consists of numbers running horizontally across the top of the print and letters vertically down the side. The grid divides the print into smaller blocks, each with a unique number and letter designation. Equipment mentioned in notes on the print and interconnection points from other drawings are referenced by a letter number designator. To locate equipment using the grid system, first obtain the equipment coordinates in the notes section or from another print which references the equipment. Next, locate the letter designator on the side of the print and trace a horizontal line across. Then, locate the number designator at the top of the print and trace a vertical line down. The point where the two lines intersect will be near the equipment being sought. As changes to a component or system are made, the prints must be updated to reflect those changes. These changes are tracked in the revision block of the print. Prints are originally issued as Rev 0. As revisions are made, an entry is placed in the Rev block. This entry provides a revision number, a title or summary of the revision, and the date of the revision. Each time the print is updated, the Rev number in the title block is increased by 1. Personnel can verify the latest approved Rev to a drawing by using the Engineering Plant and Facilities Management (EPFM) application available through Insight. There are two common methods of illustrating revisions on the graphic portion of the print. The first method is the cloud method, where each change is enclosed by a hand-drawn cloud shape. The second method involves placing a triangle with the revision number next to the affected portion of the drawing. The cloud method is used to indicate changes from the most recent revision only, whereas the triangle method is used to indicate all previous revisions to the print. Drawings are comprised of symbols and lines that represent components or systems. Although a majority of the symbols and lines are self-explanatory or standard, a few unique symbols and conventions must be explained for each drawing. The Notes and Legends section of a print lists and explains any special symbols and conventions used on the drawing. Also listed is the additional information the designer feels is necessary to understand the drawing. Because of the importance of understanding all of the symbols and conventions used on a drawing, the Notes and Legends section must be reviewed prior to use of the print.